Well, hello geometry students. Welcome to our lesson on measuring segments. Just wanted to kind of brief you on how this segment is, or this lesson is laid out. First off, if you want to put your piece of paper and lay it out just like mine, your notes need to look exactly like mine. I am taking what we call Cornell notes, where we kind of have a line drawn down the left-hand side of the page, a title at the top, and on the left-hand side goes topics and some descriptions. On the right-hand side is where we put our actual notes and we write our stuff down. So go ahead and make sure your notes look exactly like mine. And I wanted to go over first the fact that you have the ability to pause and rewind me as necessary. There are some times here where I will tell you to pause me and write down the examples, but if you need to pause anytime, please take advantage of that. All right, so on measuring segments, first off, I wanted to just remind us what a segment is. A segment is a piece of a line, has endpoints on either side, and we have to label those endpoints with the capital letters. So this is segment AB. First thing we start with is a segment addition postulate. The segment addition postulate says that if we have points A, B, and C are collinear, remember collinear means together on the same line, and B is between A and C. Okay, so let's draw a picture of what that looks like. If A and B are collinear, so we have a line, and then we're going to have point A, point B, and then point C at the end. Okay, if that's what we have, then our postulate says that AB plus BC is going to equal what just AC by itself is. Sounds pretty simple, but make sure you have that into your notes there. Okay, a quick example of that is if we have AB is 10, BC is 13, what is the length of AC? You might want to pause this video and write that down in your notes first, and then draw a diagram. So if we have AB is 10, BC is 13. So here's A, and then B is somewhere in the middle, and then C is at the end. Okay, AB has a length of 10, BC has a length of 13. What's the length of AC? Well, we can take this by the same postulate up here. AB plus BC equals AC. I can just substitute AB is 10, and BC is 13, so 10 plus 13 is 23. Again, sounds simple, I hope it is. You can think of this maybe as if you're on a football field and you run 10 yards, and then you run 13 yards, together you ran 23 yards, but we have a segment. Okay, we can then make this a little more in depth if we make this kind of an algebra problem. So here's example 2. You might want to pause this video and copy this example down. Okay, now E is between D and F on a line segment, as we can see as a diagram here. DE is 5, EF is 2x plus 1. And then DF, all of DF, is 5x minus 6. Okay, solve for x and find the lengths of EF and DF. So first thing is we can say that with this, we know that DE plus EF is going to be equal to what DF is. So from that now I can rewrite this with my algebra. So DE is 5 plus 2x plus 1, which is EF, is going to be equal to all of DF, which we know is 5x minus 6. So we need to solve for x. So this is just like our algebra expressions. We can combine that 6. So I have 2x plus 6 equals 5x minus 6. Okay? Get the x's on one side, so subtract 5x from both sides. So 2x minus 5x is negative 3x plus 6 equals, what's left on the right-hand side is a negative 6, because those canceled out. And then I got to subtract 6 from both sides. So those cancel out. Now I have negative 3x equals 6 minus 6 is negative 12. Okay? And then I have got to solve for x, so divide by negative 3 on both sides. and that reduces to 1. So now x equals negative 12 divided by negative 3 is positive 4. So I know x equals 4. All right, this also asked us to find the lengths of EF and DF. You can see that there's an algebra expression for that. So 2x plus 1 and 5x minus 6. So if I want to find the length here, I got to plug in what I got for x, which is 4. So to actually find the length of these things, I can put 2x, which would be 2 times 4 plus 1. 2 times 4 is 8 plus 1 is 9. All right, I can also plug it in for here. I've got 5 times 4 minus 6. 5 times 4 is 20, minus 6 is 14. Okay, and we can tell that adds up because 5 plus the 9 is equal to that 14 that's right there. So we know we did it correctly. All right, our next example involves a midpoint of a segment, as we can see on the left-hand side. Let's first remember what a midpoint is. If we have a segment, I'm going to call my segment segment XZ. Okay, exactly in the middle is going to be another point. I'm going to call that point Y. And if that's the exact midpoint, I can also mark this. This segment will be congruent to this segment, and I can label that XY is congruent to YZ. Okay, and notice I did not put lines over top of these segments here. If there's no line, that you can understand it's just going to be a segment. All right, so example 2 says if H is the midpoint of line segment GK, GH equals 4x minus 5, and HK equals 11 plus 2x, determine the length of GK. So we got to label our diagram first. We know that GH is 4x minus 5, and then HK is 11 plus 2x. Determine the length of GK, the whole entire thing. Well, if this is the midpoint, I can label that as this segment being congruent to that segment. And if they are congruent, that also means that they're equal. So for this, GH is going to be equal to HK. So I can write it out with my algebra then, algebra expression that I have. 4x minus 5 is going to be equal to 11 plus 2x. Okay, just solve for x, so I subtract 2x from both sides. I like to get my variables on the left-hand side, whether it be positive or negative. 4x minus 2x is 2x, minus 5 equals the 11 that's left over. I don't know why my equals keeps getting erased. All right, then add 5 to both sides. 5's cancel out, so I have 2x equals 11 plus 5 is 16. And then lastly, divide by 2. So I get a value of x equals 8. Okay, I solve for x, but what's the question asking? It's asking for the length of GK. So I can go back in and put x back in there. If x equals 8, that means 4x is 4 times 8 minus 5. All right, 4 times 8 is 32. 32 minus 5 is 27. So this is 27. Over here, I should get the same thing. Let's double check it. 11 plus 2 times that 8. Okay, 2 times 8 is 16, plus 11 is 27. And now, like our segment addition postulate, determine the length of the whole thing, GK, it's going to be 27 plus 27, and that'll give us a value of 54. All right? So that's all we have for segment addition postulate. Hopefully those examples made sense. If not, please go back and rewind. Also, give me some feedback on what you thought about this lesson, if I talked too fast, or if you liked the way it was presented, or stuff like that.